Well, congratulations, you made it to significant testing. You probably just got rid of doing some confidence intervals, and now we're going to do some significant testing. So we're going to try to combine all the things that we talked about, all right, or that you learned this past year in stats. And actually now we're going to do some testing of significance, all right? And we're talking about today is how to state an appropriate hypothesis for a significance test about a population parameter and interpret a p-value. What is a p-value and how do we interpret that? And make an appropriate conclusion for significance. So here are some notes if you want to jot them down. Okay, what's a hypothesis? Well, a hypothesis is where we have a null hypothesis. Now this is really important. So the null hypothesis can be associated with, right, a mean and a proportion. Okay, and usually the null hypothesis is equal to a null value. Now that's a value they give you. So either they'll say they assume the population, the true population is this, or the mean population is this, and the true population of this is this, and we want to state that population. So whenever you're doing null hypothesis, you want to state the population that you're talking about. Now with every null hypothesis, we'll be testing all right, hypothesis. And the thing we're going to test is known as the alternate hypothesis. So we're going to see if if we have evidence for the alternate hypothesis to be true. And so the alternate hypothesis, or H sub A, is either a mean or proportion, and that's going to be less than the null, greater than null, or not equal to null. Usually it's less than or equal to, but it can be less than or greater than, but sometimes it cannot be equal to, but then we have to do some other additional things when we do our p-value. Now, a p-value is the probability of getting the results or more extreme purely by chance. So when we talk about a p-value, that p-value, I'm just going to change this up real quick. A p-value is when we do a 95% significance test, all right, is we really have a normal curve, okay, and we're trying to figure out, okay, do we have, all right, this bottom portion? Is it in this portion, or is it in these extreme portions, okay, of significance? So we want to see, all right, what's the probability of our test statistic be true, okay? The probability that our sample, okay, occurs, okay, based on assumptions, assuming, all right, the null is true, okay? We're always going to assume the null is true. So assuming the null is true, all right, what is the probability of this occurring? Now, if the probability is in these extreme values, okay, that's going to then tell us, all right, a conclusion. Because if it's not in one of these extreme values, then this is just pretty much, it just happened by chance, all right? It doesn't have any significance. So if it's if it's not in one of these extreme values, we would say we do not have convincing evidence against the null, all right, at whatever significance level we have, and because our p-value is greater than the level of significance, okay? However, if we find that we have a p-value, all right, so either the p-value is going to be in one of the right extreme or in a left extreme, all right, so we find this p-value in one of these extremes, then we would say, okay, we do have convincing evidence that the null, all right, is actually false, is not true, okay? But it's not saying at this significance level because our p-value is less than the significance level, all right? And so when we have that, that is how we make our conclusions, okay, based on our p-value. Now the question is, how do we get these different conclusions? Well, we're going to first go through a little check, and we're going to talk about that in our next video.